When students have mastered the decade structure of the base 10 number system within 100, they are ready to extend their understanding to the number composition of the hundreds. This involves understanding that tens are a unit and can be treated as a unit. One way to represent this is in a number grid with tens rather than ones. Students should understand that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tens make 100 in the same way that 10 ones make 10. 100 means 10 tens. 200 means 2 hundreds. 300 means 3 hundreds. 400 means 4 hundreds. 500 means 5 hundreds. 600 means 6 hundreds. 700 means 7 hundreds. 800 means 8 hundreds. 900 means 9 hundreds. And 1000 means 10 hundreds. Just as with decades, students may simply memorize counting by 100 without understanding how the hundreds are composed and how they relate to each other. Students must understand that hundreds are composed of tens in the same way that tens are composed of ones. In fact, every number within 1000 in the base 10 number system can be represented by 0 to 9 ones, 0 to 9 tens, and 0 to 9 hundreds. Students should no longer think of number as representing a single counting unit. They should begin to think of number as a nested system of composite units in which a new unit is created every time 10 of an existing unit is reached. The MathRack number grid helps students to develop an understanding of the nested structure of the base 10 number system in terms of numeration, or how many. It is also important for students to develop an understanding of this structure in terms of magnitude, or how much. This involves understanding that the same number line that can be used to represent 0 to 9 ones and 1 10 and can also be used to represent 0 to 9 tens and 100, can also be used to represent 0 to 9 hundreds and 1000. In each case, we are changing the scale of the number line, which is like zooming in to see smaller units and zooming out to see larger units. Students can demonstrate their understanding of this new scale by using the same proportional reasoning strategies they have used on previous number lines. For example, consider this dot. It could plausibly represent the number 470 or the number 480. If we look closely, we can see that it's a little bit closer to the midpoint, which would be 450, than it is to 500. That tells us this dot must represent the number 470. Students who have successfully completed levels A, B, and C should be very familiar with these concepts of numeration and magnitude in number composition. At this stage, we are primarily concerned with the central concept of place value, which is unitizing, or using digits to count groups of items as well as individual items. We represent unitizing on the 10-frame place value mat. Students should be able to immediately determine the quantities represented by 0 to 9 ones, 0 to 9 tens, and 0 to 9 hundreds. Students should also be able to compose any number within 1000 by dragging an appropriate number of place value counters onto the mat. For example, if we ask a student to compose the number 364, the student should drag 3 hundreds into the 10 frame, 6 tens into the 10 frame, and 4 ones into the 10 frame. The student should also be able to write the number representing this quantity using digits color-coded to reflect their place value. We can also assess students' understanding of the nested structure of the base 10 number system by giving them strings which involve adding a 2-digit number to a hundred. Students should be able to complete these strings very quickly with almost no thought. We can also give students strings that involve adding 0 to 9 ones to a 10 within the range of 1000. Again, students should be able to complete these strings very quickly and with almost no thought.